Mrs. KJ here, going over part 2 of 4.04, buffers and titration. So we just finished talking about how when you have an acid, you add base drop by drop, and then boom, it neutralizes, and boom, one more drop. It's very basic. And of course, we can do the math. All right, you do not have to write this down. I just want you to listen through it. Now you're ready to calculate the concentration of the substance. So we did the lab where we changed the color and counted how many drops. Well, you can actually find the unknown molarity. So recall that you had an acid of unknown concentration and added 0.01 molar, or moles per liter, of sodium hydroxide. How do we know that this is a base? Oh, it ends in the OH, so it's a base. At the equivalence point, or when it's neutralized, you know that the total number of moles of sodium hydroxide must equal the total number of moles of hydrochloric acid since it's balanced, because the balanced chemical equation indicates that they react with each other in a 1-to-1 ratio. Because you know the molar concentration of NaOH and the volume you added, which was 16 milliliters or 0.016 liters, you know how many moles of NaOH you have. So calculate the concentration of HCl solution from the titration. So first we find how many moles of sodium hydroxide we have from the burette. We know that the molarity is 0.01. We use 16 milliliters, so moles per liter gives us our molarity, and then we can find our moles of sodium hydroxide to be 0.00016. And we know that the number of moles of sodium hydroxide equals the number of moles of hydrochloric acid because of the balanced chemical equation. The coefficients are both 1s, so the ratio is 1-to-1. Now that we know how many moles of HCl we had, and we started with 80 milliliters, we can convert that to molar, and they did times 1,000 milliliters. You could just change this and say 0.008 liters down here, and that gives you 0.002 molar HCl. Again, you don't have to know the math. There's not going to be any problems on this portion of the math. I just wanted to show it to you. Here are a few last words about titration. So far you have learned only about titrating to find an unknown acid concentration. Well, look at this. We can do the opposite. We can start with a base. Look at that, pH 13, 13, 12, boom, equivalence point. Its pH is 7. What does that tell you? That it's neutral. And then boom, you just add a little bit more, and now it's an acid. So you can do titrations either way, base to acid or acid to base. It is possible to stabilize the pH of a solution and to determine the concentration of an acid or alkaline solution. What does alkaline mean? It means that it is a base. So buffers help maintain or keep the pH of a solution at a constant level. Buffers are mixtures that can absorb or release H+ ions to keep the pH constant. So if we add an acid, acids give off H+ and that was the buffer absorbing it, sucking it in, going, woohoo, give me those H pluses to eat. Or if you put in a base, OH, that was the buffer getting rid of H+ ions to give to the base, to neutralize it, to keep the pH constant. Titration is a carefully controlled neutralization reaction. So we take an acid plus a base, makes what? Water and a salt. And the titration is when you have a solution of known concentration is added to another whose concentration is not known. This drop-by-drop procedure helps pinpoint the exact concentration of an unknown solution. Then we also have to use an indicator. An indicator changes color at a certain pH to help in the monitoring of the progress of the titration. And the indicator tells you if it is acid or base. For example, what color do most indicators turn in a base? Most turn blue, except for phenolphthalein, that turns a bright pink. And in an acid or neutral, phenolphthalein is clear. But most indicators are what color when it is an acid? They're red. And most indicators are what color at neutral? usually green. So pH, stabilized or kept constant by a buffer, and it's determined by the titration, which uses indicators to change color to show the pH, and titrations are based on neutralization reactions. All right, go ahead and do the worksheet.